Okay, so welcome back, kiddos. Now we are moving on to Unit 13. So now we're going to talk about probability. So this is something that you talked about in a few years ago. So let's get in deeper to it. So probability of an event happening. So first off, what does probability mean? Okay, so you may have heard this. Probably would happen, right? So the probability is how likely is something to happen. How likely is something to happen? Okay. So that's the probability of something. So we can calculate the probability. Okay, so when we calculate it, this is the formula that we're going to use. Okay, so we're going to say the number of ways it can happen, and we're going to divide that by the total number of outcomes. So this is the total number of ways it can happen. Okay, so that's the total number of ways it can happen. And so then the number of ways it can happen for what you want. Okay, so what you want over what can happen. So let's take a look at some examples. So first off, the examples are rolling 4 on a die. So a die, what's a die? A die is a single dice. Okay, so this will come up on your test coming up. Okay, so a single die. So the number of ways that you can roll a 4. Okay, well, there's only one side with a 4 on it, so the number of ways it can happen is 1. Okay, now the total number of outcomes are 6 because there's 6 faces, right? Because you could have a 1, right? You can get 2, you can get a 3, you can get 4, you can get 5 or 6, right? On a dice, right? So you got 6 places. So the probability of getting a 4 is 1 out of 6. Okay, so 1 out of 6, sometimes they'll ask as a percentage. So if we type that into our calculator, if we use alpha, okay, then y equals, okay, then the enter button, it will give us a fraction. Okay, but otherwise, if we just put 1 divided by 6 into our calculator, it'll give us approximately 0.1666, right? And it keeps on going. Okay, and we can put a bar right there to tell that the 6 keeps on going. Okay, so if we want to put it as a percentage, what we would do is we're going to move the decimal 2 places to the right. So to get a percentage, that would be 16.66%. Okay, so for percentage, move the decimal 2 places to the right. Okay, so when you're doing a percentage, you're going to move the decimal 2 places to the right. So they're going to ask us different ways. If they want the probability, they usually just want it as a fraction. They may ask as a percentage, which means we'll put in a decimal and then move it 2 places to the right, or they may ask for it as a decimal. So it depends on how they ask for it. All right, so let's move on to our second example. So on this one, it says there are 5 marbles in a bag. Okay, so we have 5 marbles. 4 are blue and 1 is red. What's the probability that a blue marble gets picked? Okay, so blue, so the number of ways it can happen are 4, right? Because there's 4 blues. Now, what's the total number of outcomes? There's 5 marbles, right? So if there's 4 blues out of 5, then it is a zero point 0.8 possibility. Now, what if they said they want it as a decimal? Then we would say 0.8, right? We know we can just, that's the same thing as 0.80, right? We would just add that 0 to the end over there. Then we'll just move our decimal 2 places to the right. So if we do that, then that's the same thing as 80% chance, right? So it just depends on how they ask for the answer. All right, so keeping that in mind, let's talk about what are the possibilities of something. So if the possibilities of something, we can put them on what we call a probability line. So a probability line goes from 0 to 1, right? So 0 means it's basically impossible. There's a 0% chance, right? That's a 0% chance right over here. Okay, and then certainty is a 1. Okay, and so that would be 100% chance. Okay, so the probability always goes between 0 and 1, because you can imagine with that 1, right, if it's 1.00, we move it 2 places to the right, that turns into 100%. Okay, so that's why the probability is always between 0 and 1. An even chance, what do you think an even chance would be? If it's impossible with 0, certainly will happen is 100. Then even chance is 50-50, right? That would mean we have a 50% chance either way. Okay, so that's what we call an even chance. Okay, likely is 4 out of 5, right? 4 out of 5 times you'll get it. That's likely. 1 out of 6 is not very likely, right? Only one time out of 6 are you expected to get it. All right, so that's the basics on probability. Let's start with the basics today, and we'll get into it deeper in the next couple of days. So let's look at some examples from our Delta math. So I'm going to show you 4 different examples. So this is going to be we do number 1. Okay, this will be we do number 2. Okay, so remember these as we are going through these in your practice. All right, so the first one says Savannah recorded the grade level and instrument of everyone in middle school of Rock Below. Okay, so these are the 7th grade students. These are what they played. These are 8th grade students. Okay, based on these results, express the possibility that a student chosen at random will play the drums as a percentage to the nearest whole number. Okay, so that's what they want the answer as, a percentage to the nearest whole number. Okay, so let's look. The first thing that we're going to do is we're going to find the number of ways it can happen. Okay, so it says express the probability that a student at random will play the drums. Okay, so we have the drums over here. So 14 of the 7th graders and 10 of the 8th graders. So the probability that they play drums are 14 plus 10, right? So 14 plus 10 equals 24. Okay, so we're going to use that number. All right, so then the second thing we need to do is find the total number of ways. Okay, so total number of ways would be adding all these, right, and all these, because these are all the students, right? So 24 of them chose to play the drums out of how many? So out of how many, we're going to add all those numbers, right? So we're going to say 5 plus 12 plus 14 plus 4 plus 12 plus 5 plus 10 plus 8, right? We're going to put all those in our calculator, and that would give us 70. Okay, so then we just do our calculations, right? So we said calculate. We're going to put the number on top and then the total on the bottom. So we're going to say 24 out of 70, right? Because 24 out of 70 was what we had. Now they say that they want this to, they say percent to the nearest whole number. So let's put that in our calculator. 24 divided by 70. If we do that, 24 divided by 70, that's going to give us approximately 0.3428, right? And they say they want a percentage to the nearest whole number. So for percentage, first we're going to move it 2 places to the right, right? So 1, 2. So that's going to be 34.28%. Okay, and then since they said to the nearest whole number, that's going to be 34%, right? Whole number means like whole dollars. Okay, so that's going to be our answer. So let's go and highlight that so we remember that that's our answer. Okay, so that's it. What we're going to remember is we're going to do the number of ways that it can happen for what we want on top, then the total number of ways it can happen on bottom, and then we're just going to divide. All right, so that's we do number 1. So now let's look at we do number 2. So this one says a spinner is divided into 5 colored sections that are not of equal size: red, blue, green, red, yellow, and purple. Spinner spins several times. Results are shown below. Based on these results, express the probability that the next spin will land on purple. Okay, so we want to be purple as a fraction in simplest form. All right, so let's look over here. So we said the first thing we want. Okay, so the first thing that we want is to have the number of purple. So let's see. Number 1, we're saying the number of purple, and that one's going to be 16. Okay, so next we want number 2 is the total number, right? So the total number is we're going to add up all those numbers, right? We're going to say that we're going to add all these and find our total. So we're going to say 14 plus 6 plus 12 plus 4 plus 16, and that's going to give us a total of 52. Okay, so now we're going to use those for number 3, right? So number 3, we said we're going to use the number over the total, right? So that's going to be 16 over 52. They want it as a fraction in simplest terms. So let's going to put that into our calculator. We're going to use the alpha button. Okay, then we're going to use the y equals, and then we're going to use enter if we're using our yellow calculator. Okay, if we do that, then it will reduce it into 4 over 13. Okay, so that's what we're going to do. Remember, if you're not familiar with that, make sure you ask me or ask a neighbor. We're going to use alpha, y equals enter. When we put that into our calculator, it will turn it into that. All right, so let's keep it moving to our second page. All right, so make sure that you've done those, you put those notations on there. So now let's look at our next ones. This is going to be we do number 3. Okay, and this will be we do number 4. So make sure you remember that as we are practicing that on your own. All right, so next it says Daniel owns a small business selling used books. He knows that in the last week, 60 people paid cash. Okay, so we know that's important information. Okay, 4 paid credit card and 23 paid by, 4 by debit and 23 by credit card. Based on these results, express the probability that the next customer will pay with a credit card as a fraction. Okay, so that's what we want to know, as a credit card. Okay, so let's just go through the steps. So we know the first step, number 1, is we need to find the number for what we're looking for, right? So what they're saying for credit card, so this says cash is 60, debit card is 4, credit card is 23, so not debit card, so 23. So the number we're looking for is 23, right? 2 is the total. Okay, so the total is going to be, what are the possibilities, right? It could be cash, debit card, or credit card. So that means the total could be 60 plus 4 plus 23. So the total number of possibilities is 87. Okay, so the total possibility is 87. So the third thing is the number we want over the total of possibilities. So that's going to be 23 over 87. Okay, and so they want the fraction in simplest terms, so let's put that in our calculator. If we do that, it still comes back as 23 over 87. All right, so that's it. So hopefully you're getting the hang of it. So that's another style you're going to see. This is the fourth style. So this is in a popular online role-playing game. Players can create detailed designs for their characters' costumes or appearance. Juan sets up a website where players can buy and sell these costumes online. Information about the number of people who visited the website and the number of costumes purchased in a single day is listed below. Okay, so I know these are a lot of words, but this is how they do these on the test. So 30, we know this is the math stuff, right? We see the numbers. 31 had no costume. 26 had one, and 2 had more than one. Okay, so this is what they want to know. Based on these results, express the probability that the next person will purchase exactly one costume as a decimal to the nearest hundredth. Okay, one costume as a decimal to the nearest hundredth. Okay, so the number 1, we need to find the number of possibilities for what we want. So we said for one costume. So that's more than one. 1 is 26, right? So we know that needs to be 26. Okay, 2, the total. Okay, the total number of possibilities are adding up these numbers, right? So we're going to say 31 plus 26 plus 2, and that's going to be equal to 59, right? 59. Okay, so then the third thing, we're just going to put our number over our total possibilities, right? So that's going to be equal to, if we put that 26 over 59, now they want it as a decimal, right? So if we put that into our calculator, it's going to be approximately 0.440677. They want the hundredth, so hundredth is that 4, right? So we ask the 0 what to do with the 4. That tells us to keep that 4, so we're going to keep it 0.44. All right, so that's it. All right, so now let's move on to the last part of our notes for today. Moving it up, but this is, we got that, so this is just a little bit more difficult. All right, so conditional property. Okay, so now we're going to move on to something else. The Before we were talking about what's called independent events. So this is conditional probability. Conditional probability means the likelihood of likelihood that something will happen given that something else has already happened. Okay? So it's the likelihood that something will happen given that something else has already happened. Okay? So independent events are independent, meaning that each one is not affected by other events. So, like we talked about before, tossing a coin. So each toss of a coin is a perfect isolated thing. Okay? What what it did in the past will not affect the current toss. The chance is simply 1 in 2 or 50%, just like any other toss. So each one is an independent event. So even if it's heads and then heads and then heads and then heads and then heads, you might think the chances of it getting heads is more likely than tails, but no, it's still 50%. Still 50%. It has no chance, no bearing on what happened before. But now we have what's called dependent events. Dependent means it can be affected by previous events. Okay, so let's look at our example on this. Okay, so this is going to be our we do number 5. Okay, in a class of students, the following data table summarizes the gender of the students and whether they live in a class. I'm sorry, whether they have an A in the class. What is the probability that a student has an A given that the student is female? So this tells us that it's conditional because it says given. Okay, so it says what's the probability that a student has an A given that they're female? So two different things. Okay, so we see over here this total says these are the number of females, 5 that have an A, 5 females that don't have an A, 3 males that have an A, 2 males that don't have an A. So what's the probability a student has an A given that they're a female? Okay, so here's how we're going to do it. The first step that we're going to do is we're going to total all the columns. Okay, and columns are the ones that go up and down. Okay, so let's total all these. So 5 plus 10 is 15. Okay, then 3 plus 2 is 5. Okay, second thing we're going to do is we're going to total all the rows. Okay, and the rows are the ones that go like this and this. All right, so we have 5 and 3, so we're going to say that that is 8. Okay, and then 10 and 2, we're going to say that is 12. All right, now here's the thing. This is how we check ourselves. This should be correct. 15 plus 5 gives us 20, right? And then these should add the same too. 8 plus 12 should give us 20. So this is how we should check it. So we got to check it. Check it to make sure it's right. All right, so now that we have all our totals on our columns and total our rows, now we can do our second step. So the last step. So number 3, we said the number of what we want over the total possibilities. Okay, so what we want is that probably a student has an A, right? So that given that they're female. So if they're female and they have an A, that's 5, right? So female and they have an A, that's going to be 5 out of the total possibilities. So the total possibilities, given that she's a female, is not the total of 20, because that's the total students. So given if she's a female, there's only 15 possibilities. So it's not going to be 20, it's going to be 15 right there, right? So 15 out of 20, if we put that in our calculator, 5 out of 15, that will reduce into 1 out of 3. So we're going to use that alpha, y equals, and then enter. Okay, if we put that in our calculator, then that will be our answer. Alright, so make sure you do all these. If you have any questions, just let me know.